Hello, everyone. Thanks so much for joining us today for OPN 307, also known as Pronto, an IaC suite for managing Cassandra at scale. My name is Aaron Elman. I'm with AWS, and I'm lucky enough today to introduce you to Achal Kumar, who leads the engineering team responsible for persistence as a service at Intuit, and Ben Covey, who's the lead engineer for Pronto. Now, Intuit went all in on AWS in the first place so that it could build and innovate faster on behalf of customers. Open source has further accelerated Intuit's ability to deliver great stuff for its customers. Intuit's a big contributor to open source. They have dozens of popular projects. Argo is a popular one you may have heard of, one of the most popular open source projects for getting stuff done with Kubernetes. Argo was started at Intuit, as were dozens of other projects. And we're super excited to have worked closely with Intuit in support of their open source initiatives for the benefit of the open source community as a whole. Now, today you're going to hear about one of Intuit's most recently open source projects, Pronto, from a couple of people with nearly a decade of experience managing mission-critical Cassandra infrastructure at scale. With that, I'm going to hand it over to you, Achal. Thanks.
Thanks, Aaron, for the introductions. Hello from Intuit. I hope you all know Intuit. We are famous for our products like TurboTax, QuickBooks, ProConnect, Mint. We serve consumers, small businesses, self-employed, and we are obsessed with our customers. What does our team do? My team provides some multi-tenant data persistence as a service. What it means, our clients are primarily internal Intuit teams who need a persistent store. So instead of using DynamoDB or Cassandra, they would come to us and we provide them a client SDK. And what they do is then they define their own logical schema, and that's it. They start using our SDK and our APIs to store, retrieve, and search their data. On top of that, we also provide encryption, access control, and above all, a polyglot persistent solution for our clients. So they write data to a NoSQL service, and they get data available in search. So for our fully managed NoSQL service, we have been using Cassandra for almost 8 years now. And we use S3 for our document store. Above all, we support TurboTax. I hope most of you guys use TurboTax to file your taxes. What does that mean for our service? It means that we have to be highly available, highly performant, and highly secure. We have almost more than 400, 500 Cassandra nodes in the cloud today, and we serve more than 140,000 transactions per second. So now why are we here? We are here to tell you about our journey, our story, and also about our open source automation tool. So 4 years back, Intuit was in our own data centers, and we started our journey to the cloud. But before that, managing Cassandra was a hell. It was a daily, fight with Cassandra. It was operational struggle, it was crazy. Our installation and configuration was manual. It was prone to human errors. We were dependent on a single Cassandra expert to perform DB activities, and the pace of upgrades was really slow. My team used to spend more time on RTB and less time on new feature development. The good thing was that at that point of time, roughly, Intuit decided to move to AWS completely. And at that point, we said, okay, enough is enough. Let's step back. Let's figure out what needs to be done to make our lives better. And we set some basic principles. We said we want to automate everything about Cassandra. Everything. Nothing should be manual. You are not allowed to SSH to a node. Nodes going down should be part of life in the cloud. It's the cloud. Nodes go down. You should not be getting up in the middle of the night to fix a node, And above all, developers should be automating and managing it. It's not a single person's job. And I also gave a challenge to my team. I told my team, if you make it as so simple that I can do it, then I would be happy. So those were the principles set, and then we went on our journey. It took us almost a year to reach where we stand today. And what we have today is everything is automated in Cassandra. There are some things which are seamless. Nodes go down, they come up. We don't get up. We don't wake up in the middle of the night to do anything. And my team spends less time on Cassandra and more time developing new cool features for our customers. So once we did that, we realized that there's nothing available in the open source community for companies to do this. So we also decided to open source our automation suite. And Ben is going to talk about that in the next few slides. Thank you and have a wonderful day.
Thanks, Achal. Hi, I'm Ben Covey. I'm an engineer at Intuit, and I've spent the last year or two working on Pronto. Achal just covered who we are and why we needed something like this framework. So now let's dig into what Pronto is and how it was built. Why should you care about it? It is an open source suite of open source tools that lets you get up and running quickly with Cassandra in the cloud. Every team that maintains a Cassandra cluster has to implement everything more or less from scratch and ends up relying on an ad hoc patchwork of support from a variety of sources. And Pronto is an attempt to collect all of that in one place and put all those best practices in a single package. Finally, it's infrastructure as code, which is just an exciting buzzword that a lot of companies are spending a lot of time and effort on. So it's interesting to consider from that standpoint too. I've said a little bit about Cassandra, but what is it and what makes it such a challenge to work with? Well, it's an incredibly popular distributed NoSQL database. From a pure numbers standpoint, it's right up there with MongoDB. Something that makes it a challenge is that it works in a cluster fashion. And the term cluster is a little overused and sometimes misapplied. A group of homogeneous application servers behind a load balancer is not a cluster. What makes Cassandra different is the fact that each node has its own distinct chunk of work to do, and they are all unique and they all need to work together. Cassandra is very powerful, and with that power comes a lot of complexity. To be honest, I'm not a DBA or a Cassandra expert. The list of steps involved in safely restacking a cluster makes my skin crawl, but I work with Cassandra experts and I benefit from their experience. I hope it speaks to the usefulness of Pronto that I am able to get a cluster up and running quickly despite my lack of domain knowledge, and my Cassandra expert colleagues are happy with the end result. More interesting question here is, why is this talk in the open source track? This is a project that didn't have a definitive beginning. It grew organically in 100 different ways, and then one day it was Pronto. How did that happen? There's three things to cover in these slides. One is the problems that we solved. Our solutions to the problems presented by Cassandra aren't novel. We're not the first, and we won't be the last. But why do these issues need to be addressed over and over? When you find yourself doing that, you may have identified a pattern, and when you identify common patterns that are applied repeatedly, you may have actually zeroed in on a need that isn't being met, and that can provide value in the open source community. So all you can do at that point is put it out in public and see who's excited about it and what kind of an audience you attract. So let's get right into the top of the list of problems here. The first one is, you as a company, or we as Intuit, you're moving to the cloud. But is that really a problem? Lots of companies, hundreds or thousands of companies, had moved their business from on-prem data centers into AWS before we did. Surely this is easy. Well, when your company comes to you and says you're moving to the cloud, there are, of course, going to be some complicating factors along the lines of, hey, we'd like it to be faster, and why not cheaper while we're at it? We'd like it to be more resilient, easier to maintain, deployable within hours in a commit to production fashion. And oh, by the way, we're turning off the lights at the end of the year, so we need it really, really soon. All that said, still, it is moving stateless ephemeral applications into the cloud. It's really well understood. So what about one of the most popular databases in the world? Let's take a look at what's available there. There are a few fully managed offerings. Amazon itself has key spaces. DataStax recently released Astra into general availability, and Instacluster has been around for a while. It bears pointing out that when we started our journey, none of these were viable options yet. And even if they did exist and were viable, we might have evaluated them and gone with our own cluster management solution anyway. Why? Well, in Instacluster's words, they say they customize and optimize your configurations for you. And that sounds great. It is great. If you know you want Cassandra and you're not interested in running your own cluster, any of these might be perfect for you. Well, what if you are like us and you've already done a lot of your own customization and optimization? We've spent years honing our in-house clusters, working with our vendors, and we've got everything humming along. We support some of the highest volume applications on the planet. So what if you need to run your own infrastructure for performance reasons, or for liability reasons, or because you've got some weird edge case you need to support? Is there anything out there to help you? And by you, I mean us. Let's see what's out there for self-managed solutions. There's nothing. There are no frameworks available, no suites of tools, no repositories of best practices, just do it yourself. So that is the definition of problem number one. Now, how do we solve it? If you're going to manage your own Cassandra cluster in the cloud, the first thing you need to do is decide on your standards. And for us, that meant operating in a multi-region, multi-AZ fashion for high availability and disaster recovery purposes. It meant isolating our data stores in a segregated set of data subnets, a whole data tier, with no access to or from the outside world, meaning, by the way, that runtime provisioning is impossible. You can't reach out to Yum repositories or anything like that. You are locked down in a hermetically sealed vault, so you need to come in with a fully baked golden image ready to go with every package pre-installed. And ideally, we'd like to orchestrate everything from a build platform, like Achal said, all automated in pipelines with absolutely nothing being manual. This is the platonic ideal we're aiming for. So how do we make this happen? The next step is to choose tools that are appropriate to your situation. You evaluate everything on a case-by-case basis, and this is what we arrived at. First of all, configuration management is the installation and updating of software on an existing piece of hardware. So it's almost everything you do in data centers. We used Chef for that. Now we'll be using Packer, because in the cloud, what you're probably talking about is the initial provisioning of a blank node in order to create that golden image I just mentioned. Next, provisioning is the deployment of cloud resources. There really isn't any such thing in a data center unless you count unloading physical hardware off the back of a truck. In AWS, we'll be using Terraform as opposed to CloudFormation. And for runtime operations like starting and stopping your cluster or updating configuration files, in a data center you would have human operators SSHing in and doing this stuff. To automate it, we'll be using Ansible over the same similar SSH channels. I don't expect most of those tools to be controversial. Packer is completely standard, and there are alternatives to Ansible, like SSM run command, but it's pretty standard too. It is worth talking for just a minute about why we chose Terraform specifically over CloudFormation. There are a few features of Terraform that we liked for our specific use case. One is that it separates the planning and execution phases of a deployment, meaning that you can examine a bunch of deltas in a dry run fashion before applying any change. Next, it notices and handles configuration drift, meaning that if someone goes in manually and tweaks a rule in a security group, Terraform notices that and rolls that change back the next time you run it, and everything is done in a declarative fashion. It doesn't attempt rollback on failure, meaning if you get 95% of the way through a deployment and everything's fine, but then there's something that bombs out in the last mile, Terraform exits with an error and leaves everything as it is, giving you the opportunity to go in and fix stuff and then deploy the last 5%, as opposed to just tearing down your whole stack and deleting everything and winding it back. These are features of Terraform that are differentiators that make it different from CloudFormation. And again, for a different application, these might be negatives. For our application, for our use case, for Cassandra, we find them to be positives. Furthermore, Terraform is cloud agnostic, and this is an AWS conference, so any other cloud providers will go unnamed, but that's out there. It's also open source, has a huge community, which often means that Terraform has support for new AWS services before CloudFormation. And finally, it feels like programming, which is vague. So one more quick tangent on the topic of DevOps. DevOps is a really new field. The industry created it by collapsing inward from two different disciplines, development and operations. And the way you approach DevOps can be partly determined by your background, which of these two fields you started in. I'm a developer, and devs like abstractions and they like code they can reuse. Whereas operations folks end up responsible for the health of thousands of servers in the middle of the night. So they're less interested in your thoughtfully chosen programming paradigms than they are in something concrete that will work correctly and immediately and 1,000 times. So anyway, the way Terraform handles modularity and parameterization acts a lot like code abstraction, which feels familiar and appeals to me as a programmer. But there is value in both of these mindsets, so you may feel differently. For us, we have chosen the tools we're going to use. We've solved problem number one, Packer, Terraform, and Ansible. But problem number two, we still have to solve for the idea of a database running on ephemeral virtual hardware. Stateful data stores that rely on static IP addresses and concrete, durable storage devices do not lend themselves to an elastic cloud-based environment. You're probably familiar with the pets versus cattle analogy that people love to use. It describes the way we think about virtual machines in the cloud versus servers in a data center. If a server gets sick, you nurse it back to health, and that's a pet. If an instance in AWS gets sick, you terminate it and get a new one. That's cattle. Cassandra nodes are not cattle, but the nature of work in the cloud kind of demands that you treat everything as cattle. So here's the way it doesn't work and can't work. One big auto-scaling group with all of your Cassandra nodes in it, seeds and non-seeds homogeneously swimming in a pool together. Our vendor saw that we were using auto-scaling groups and said, hang on, you can't do that. If more than one node goes down and gets replaced, won't they get mixed up? Yeah, fair point. We cannot use ASGs for their elastic scalability, but we can still benefit from auto-scaling. If we keep every node in its own auto-scaling group of size 1, then when the instance dies or gets terminated during restacking, it will be replaced with all of its uniqueness intact. And the way we accomplish that is with a pool of EBS volumes, a pool of elastic network interfaces, and an EC2 tag on every auto-scaling group. When nodes are replaced, they take a look at their EC2 tag, and then they reach out into the pools to find the correspondingly tagged EBS volume in ENI. They reattach them, start their services, and the node rejoins the cluster transparently with no downtime. That's problem number 2 solved. We have some ideas now about how to run a stateful database in the cloud. So a quick review. We've got Packer doing all of our configuration management. It bakes a golden image consisting of Cassandra and all its dependencies, plus a number of Boto 3 scripts we've written in Python for doing things like locating and reattaching EBS volumes during node initialization. We've got Terraform doing all of our provisioning, which involves auto-scaling groups, EBS volumes, ENIs, and a whole bunch of other stuff, all multiplied by the number of nodes we want in our cluster. Finally, we're using Ansible for runtime operations, starting and stopping the cluster, so forth, remotely. In our case, all of this is automated in a pipeline from a Jenkins build platform, but you could just as easily use CodeStar or any other orchestrator. This diagram, by the way, is deceptively simple. There's a lot going on here, but it works beautifully, which actually leads to another problem. And the problem is that it does work beautifully, and other people at Intuit noticed and wanted to use it for their own Cassandra clusters. The issue here is we had a lot of cooks in the kitchen early on and a lot of ideas, and under the hood it looked a little like a Moroccan street market. There were 1,000 moving parts, and if you were the one who put them there, you knew what was going on, but an outside observer was probably going to be overwhelmed. So how do we educate new users? No problem. Let's just point them at our GitHub repo, let them read our documentation, and get started. Oh no, actually there are 8 GitHub repos, which is way too many, obviously. In fact, I made one of these up. And I can guarantee you that half of my coworkers would not be able to tell you with 100% confidence which one of these is fake. It's that one. That's the fake one. But the rest of these were actually all involved at one stage or another of our Cassandra build and deploy pipeline. Part of the reason for that, of course, is that our Packer builds don't only produce Cassandra AMIs. They produce a bunch of different AMIs. Our Terraform doesn't only deploy Cassandra clusters. It deploys a wide variety of things that all work together. So we organize the tooling for our team's use. But other teams who just want the Cassandra parts don't care about all the rest. How can we simplify things for them? Well, as in any large project, chances are there are some dusty corners that you've forgotten about, and you need to start by relearning everything. That was my first step. And while you're doing that, you should not take sanity for granted, which is something I never do if it's a piece of code I've been even partially responsible for. Why is this here? Maybe it doesn't need to be. So go ahead and blast it apart and put it back together from the ground up, but better this time. We have the technology. If engineers were given the opportunity and the space to rewrite things on this level, chances are collectively as an industry we would retain about 10% of our lines of code year over year. Nobody likes code they wrote last month. So where are we now? Everything's packed up in one repo, nicely organized. All the code is cleaned up. Anything extraneous has been removed. And by the way, that link should be live if you want to give it a click and go take a look. And let me show you something cool. The internal version of this repository has 11 contributors now, which it's not a huge number, but it means that there are 10 people other than me who all thought this was a worthwhile project and wanted to add something to it. And that's exciting to me because it means I know those people are improving the tools in ways that I either couldn't find the time for or couldn't even imagine on my own. So what does that indicate? To me, it means that inner sourcing works. Exposing these tools to other engineers at Intuit was a massive net positive. And I'm hoping that open sourcing works too. And we can exponentially increase the number of brains on the problem. So please do take a look. If you've got some baseline level of familiarity with the tools involved, I'm confident you can get a cluster up and running very quickly. What kinds of contributions are on my wish list right now? We specifically use DataStax Cassandra, meaning we've got support for things like Ops Center and DSC Studio built into Pronto at the moment, but there are other DataStax features like tiered storage that we would like to add. And speaking of DataStax Cassandra, it would be nice to modularize this repo and support vanilla Apache Cassandra too. And by the way, since all the tools we chose are cloud agnostic, this whole framework should be capable of operating in any other cloud provider, which shall remain nameless. But that would be a great addition also. And what else? Anything else. Stuff I can't even imagine. That's the point. That is the cool thing about open sourcing. Give me more brains. So thank you very much for checking out this session, and I hope some of you will choose to give the repo a look. If you have any questions or comments, there's contact info on this slide, and it would be fantastic to see some contributions. With that, please complete the session survey, and thank you very much.